I'm going to be talking about ankle-brachial pressure index, or ABPI, and this is a test that we use in order to assess the severity of peripheral vascular disease. So in order to explain how the test works, first we have to have a look at the pathophysiology of peripheral vascular disease. So first let's start by looking at a healthy blood vessel. So if you imagine it like a pipe, the blood can flow very easily through this blood vessel. When you have a blood vessel that's developed atherosclerosis, what happens is chronic inflammation and activation of the immune system in the artery wall causes lipids or fats to attach themselves to the artery wall and build up, and over time these become fibrotic and hardened. So you end up with what's called stenosis, or narrowing of the blood vessel, which makes it much more difficult for blood to flow. So if you compare the blood flow through these two blood vessels, the healthy one and the atherosclerotic one, the healthy one clearly has very good flow all the way through, whereas the atherosclerotic one, you get a build-up of blood behind the plaques and only a very narrow trickle of blood through the diseased part of the blood vessel. So if you look at this diagram of the full human body and the different main arteries in the body, and you imagine that the femoral arteries here have become diseased with atherosclerosis. Now what happens is this causes a reduction in the amount of blood that can flow, arterial blood that can flow to the lower limbs. So this is what we call peripheral vascular disease. And in order to measure the severity of this atherosclerotic disease in the femorals and the distal vessels, we do the ankle-brachial pressure index. So how do we do this? Well, we take a blood pressure reading at the brachial artery on the upper arm, and we take a blood pressure reading at the ankle, at the lower leg. And by comparing the two readings, we can find out the severity of the peripheral vascular disease. So how do we actually work it out? Well, we take the ankle reading and we divide it by the brachial reading. And this gives us a ratio of the two readings. So if you imagine the ankle reading is 120 and the brachial reading is 120 systolic, then you end up with a reading of 1 because equal amounts of blood are getting to both the ankle and the brachial arteries. This means that there's no peripheral vascular disease and we have a healthy person. Now imagine the person has peripheral vascular disease. Now we have an ankle reading of, let's say, 60, and we have a brachial artery systolic blood pressure of, let's say, 120. Now we have a result of 0.5. This is the ratio between the two. So to quickly summarize what the results might mean, if you had a ratio above 0.9, that will be classified as normal. A result between 0.6 and 0.9 corresponds to mild peripheral vascular disease. A result between 0.3 and 0.6 is moderate to severe peripheral vascular disease. And a result less than 0.3, and you'd be very concerned because this represents severe disease or critical ischemia of the limb, because so little blood is actually managing to squeeze through that narrowed artery to the peripheral tissues that you're most likely to lose toes or a foot. So you can see that the lower that the ankle pressure is compared to the brachial pressure, the more significant the peripheral vascular disease is. So I hope that's made sense. I hope you've enjoyed that video, and please like, comment, subscribe, start a discussion. If you have any questions, leave them below and I'll get back to you. And check out the other resources such as the website, the Instagram page, Twitter and Facebook. Thanks for watching.